Hello guys, welcome back to MathZone African Motives. Still on our mathematics for O level. This is a vector, part 2 that we are going to focus on. That is the vector 2. Remember the vector properties, right? The properties of a vector, like I said, they are most important in your calculations. All right, so this is from our NGM book 4, from question 4. We're just going to focus on question 4 and question 5. So like I said, you need the properties of the shape and also the direction that is being taken. So considering question 4, where we are given in fig 18.8, OP is given as 2a, that is from point O to the point P, we are given this vector as 2a. All right, so that is our vector 2a. And here we are given 2b, that is PQ, 2b minus 3a, and also vector OR in this case, which is given as what? Which is given as vector 3b. The arrow is pointing the direction of what? Of R. And here the direction from P to Q. Express OQ, QR in terms of A and B. Take note. Vector A and vector B. Your answer is supposed to consist of vector A and vector B as simply as possible. All right. So remember, the vector is the direction that you are supposed to take, that you're supposed to make. The direction. From which point? All right, let's consider the first vector, which is OQ. All right. Which direction are we going to consider from the point O to the point Q, like this? And provided that the direction or the route, in actual sense, which route are we going to take? We are going to move from which point to which point? Always you move from the point that you're given in the first plane, which means from what? From O. And we are supposed to end at what? At Q. We are supposed to move to begin. Our movement is supposed to begin from where? From O. The first point there. So from O, it's either I'm going to move this way, OP, then PQ, or I'm going to move this way, OR plus RQ. These are the possible directions that I can use. But if you consider this second direction, we do not have this part of QR. They are actually asking that part on the next question. So it's impossible for us to take this route to find OQ. So we are now left with only one path to follow. This is the path that we are going to follow. From O up to Q. You are going to follow this path. All right, that is, you are going to follow from O to what? From O to P. That is OP. This is the direction, plus P to Q. All right, so there we just add. There is no subtraction here. We just add the subtraction or anything you consider when you now talk about the direction vector there to say, okay, which direction am I taking? Is it am I maintaining that direction that I'm given in the original place or not? All right, so this is what you're given here. OP. From point O to P here, we are maintaining the arrow is facing P, and this is the direction that we are moving from O to P, OP. If it was PO, we are opposing, we are moving this way, we are opposing the direction, it's going to be a negative. But this one, we are moving straight in the direction. We are following the direction of the arrow. So it remains as it is, as a positive. So that's positive 2a, like this. All right, so you are, guys, you see this here, they write these vectors in bold. All right, then they can write these vectors in bold. But as for you, for these ones, for direction, you write RS with an arrow like that. Then the position vector that is now the R, they will indicate that with a dash on top. All right, do not just write letters R plus T. No, these are not, this is not algebra. These are vectors. So as we cannot present this in bold, keep on writing like in bold. No, you indicate the sign of a vector. You are dealing with a vector, indicate the sign. That's why they are writing this in bold. It's not for you to properly see that. They want you to see that this is A or this is B. No. This is the indication that they use for a vector or for matrices. But as for us, we indicate like this on top. I talked about this, all right? Or you can present it down like this, vector 2A. But remember, some of us, you're going to underline, you end up underlining that vector indication. So it's best for you to indicate it on top. All right, plus PQ. From P to Q, we are maintaining the direction also. We are moving this way from P to Q. We are maintaining the direction. So our vector is going to remain as it is, which is 2B minus 3A. So we are supposed to open the bracket to indicate the vector 2B minus 3A like this. We're supposed to open the bracket there. But because there's a plus here, the plus does not affect anything. All right, so it is important that we use that when we have got a minus. All right, the plus one does not affect anything. Everything is going to remain as it is. That means plus times 2B, we're going to have 2 vector B, 1 times minus 3A, that's minus 3 vector A. We are now collecting the like terms, just like algebra. If we are given 2A plus 2B minus 3A in algebra, we collect our like terms. So it is the same thing even for the vectors. We are going to collect like terms. That is vector 2A minus vector 3A plus vector 2B. All right, these are the like terms. So we can subtract the coefficients 2 minus 3, which is minus 1. So you're supposed to write minus 1 vector A like this. But minus 1 vector A is same as minus A. All right, plus 2 vector B. So that is how we are supposed to have attempted this question. So like I said, it is important for you to note also your presentation is not just answering the question, but also your presentation as you are answering your questions. Try by all means to present your work properly. This is the vector indication that you're supposed to have. All right, so meaning to say, after finding this, remember, guys, vector, I always say this, vector is referred to as a hence method. All right, a hence method. Remember, when you're answering those questions, where you answer the first part, then the next one, they will say, hence find this. That is the vector concept. Meaning to say, once this question is wrong, once this solution is wrong, the answer there is wrong, it affects a lot of things. Because this solution, it is exactly what the root here means. What we are given. We were finding the vector OQ from point O to Q. Just like other vectors, how were they given? Or let's consider how other vectors were they given here. OP is 2A. If the arrow is also showing from O to P, the arrow is also pointing. PQ, the arrow is from P to Q. The arrow from O to R is pointing from O to R. So if we are given OQ, the arrow must point from O to where? To Q. So we can even indicate this vector because we calculated it. And it is the exact vector of this diagram. So it means in place of that, we can substitute as what? Minus A plus 2B. So that is here. We can even write this as minus A plus 2B. Indicate it on your diagram so that you can be able to even use that solution, that answer that you have obtained to answer another question. All right, let's see if it is possible or if it is applicable for us to answer the other questions from this part. All right, let us see here. This is what we have. This is what we have. We have BQR, vector QR. Which direction, which route, are you going to take? From point Q to R. We can move this way from Q to R. We can move from Q to P, from P to O, from O to R. Using the original information, using the exact values, or we can move this way from Q to O, then from O to R. It's another route. Take note. This one is a route. We have moved from Q to R. Remember, I said you must start from the first point, this one, Q. Q is the starting point, and ending at what? At R. Starting at Q, ending at R. That is the condition there. So meaning to say, starting here from Q, we've got two ways. We can move from Q to P, P to O, and O to R. That is the route that we're going to take there. That's the first route that we're going to take. This one, like this, up to where we reach what? Q, or where we reach R. So this is QP, Q to P. You write it as QP. We are moving from Q going to P. That's QP. Plus, this one is for a movement. You just add for a movement. Where are we now? From P to where? To O. From P going to O. Remember, this is the direction. So we now move from P to O. Then from there, we move from where? From O to R. Plus OR. This is what we have. We're done. We start with the Q and with what? With R. So the moment we see this not giving us our original vector, say QR, the moment you try to join these and you are not obtaining this QR, like for an example, you write QP plus RP like this. This is wrong. We cannot move from P. It must join. Take note. It must be a P. We have got P here. It joins. It links with P. We end it at O. We start with O. It must join. Then this whole part QR is the original. The question now, QR. So if you consider this, these two are not linking up, these ones. So it's wrong. QP, this is QR. So it tells you this is wrong. Take note. All right. So you're just going to substitute there. Or like I said, we also have another way that we can also consider to find the same vector QR. The same vector QR can be obtained using this way, from Q going to where? To O, then to R. This is the direction that we're going to take now. From Q here to O, then from O to where? To R. It's another way. It's another route to be taken. We can move that way. Q to O, then from O we move to where? To R, plus OR. So if we check Q, R, this is the vector. O and O, they connect each other, which means this is true. So we can use either way. As long we have started from Q, ending at R, it does not matter. And also provided, do we have this part? We have it because we calculated this. And also when you indicated on the direction, remember your arrow, this arrow is important because we are going to see it here. You're going to see it. So that's why I said, when you indicate your vector back, the direction of the arrow is important. All right, let's use the first route that we took here. The route that we took, it's QP. From Q to P, what is happening? We are moving this way from Q to P. This is our direction. What is happening? We are opposing the arrow. The arrow is pointing this way as we are going this way. Whenever you oppose the original part that you are given here, you multiply by a negative. So that's going to be minus 2b minus 3a. Everything is affected by minus. We are opposing the vector. The arrow is opposed. So you multiply by a minus. The same thing from P to O. We are opposing. The arrow was facing up as we are going this way. We are opposing. So it is going to be a negative. Remember, this vector was 2a. So it's going to be a negative. We are opposing. It's a single term. There's no need for us to open bracket there. We open bracket because this one is an expression. Remember from your algebra. 2b minus 3a is an expression. So everything is affected. But like I said, this is a vector. So you must indicate this to show that you're dealing with what? A vector. Then from O to R, are we opposing? No, we are maintaining. We are moving in the same direction as the arrow is indicating. We are moving in the same way the arrow is indicating. So this is going to be a plus. It remains as it is plus what? Plus 3b. So that is what we have there. So from this root, we can simplify. So we're going to simplify and test with this one if we have got the same answers there. Multiply by a negative, that will be negative 2b, negative, negative, that is going to be a positive 3a. The rest, we do not have the bracket, that part. So it is going to remain as it is. It is not affected by this part of the bracket. So you're going to remain with minus 2a plus 3b. Collect your like terms, vector a and vector a together. So that is going to have 3a minus 2a. Vector b and vector b together. So this is 3b. You can even start with a positive there. Positive 3b minus 2b. Just like that. So we are going to collect the like terms. Now we have collected the like terms. Then you can subtract the coefficients. Those are the ones that we are focusing on vector A. That is where we have a focus there. Our focus is on vector A. So that's 3 minus 2. 3 minus 2. What are you going to obtain? That's 1 vector A. But 1 vector A, guys, is just same as what? 1. 1x, it's x. So 1 vector A is what? It's vector A. So this is going to give us vector A. 3b minus 2b, the same thing, 1 vector B, which is same as what? Plus vector B. So we are obtaining A plus B. Vector A plus vector B. So this here is the same as what we have here. Are we together, guys? So I want you to see this part, that we could have obtained the same answers here using this root, here. The root that we have taken, it states that we are going to move from Q to O. From Q to O, we are opposing the arrow because we got vector OQ, not QO, but OQ. So the moment you are moving this way, we are opposing our vector. We are opposing the direction QO. It follows that from OQ, you can find what? You can find QO. QO is simply, as you can see, it's simply the reverse. It was OQ. Now it's QO. QO is simply minus vector OQ. All right, what am I trying to say? Whenever you are given the first vector, let's say you calculated vector AB. Take note, this is vector AB. Then the next question, you are not using AB, but you are using vector BA. It follows that vector BA is taken from vector AB. Only that you just have to multiply by a negative. Vector BA is equal to the minus of vector AB. The minus of vector AB, meaning to say if our vector AB is given as A minus 2B like this, therefore vector BA is going to be what? You do not need a diagram for that. You're supposed to know this concept. I'm given AB. Now I'm finding BA, the opposite BA. I just have to multiply by what? A minus. Whatever that I'm having here, multiply by a minus. A minus 2B, everything by a minus. So this will give us minus A plus 2B. So from vector AB, I can find vector BA. Meaning to say from vector OQ, the one that we calculated before, we can find the vector what? QO by multiplying it by what? By a negative. Or you use this information of the diagram. The diagram does not lie. It tells you direct. The arrow is facing this way as we are moving this way. So we oppose. What happens when you are opposing? You multiply by a negative, which is the same thing as what I referred here. So it's going to be minus vector OQ. What was our vector OQ? It is minus A plus 2B. So you're given minus vector A plus 2B. This is our vector that we got before. We multiply it by a negative. Plus vector OR. Let's consider from O to R. We are maintaining the direction. We are following the direction of the arrow. The arrow is facing R. And this is the direction that we have taken. So it is going to be taken as plus 3B. So this is not going to change. It's the same OR that we had here. All right. So let's simplify and see if we're going to have the same answer as the previous one. Multiply, expand by negative, that's negative times A, which is going to be a positive. Negative, negative, that's a positive. Negative to a positive, it gives us what? A negative. So that's negative 2B. Plus 3B, which is already there. We already have this. It's not affected by any bracket. Already, the like terms are there. Minus 2B and what? And 3B. So that's 3 minus 2. 3 minus 2 is what? It's 1. So we're going to have 1B, which is same as what? As a B. So this gives us vector A plus B, which is the same as the answer that we got here, vector A plus B. There are so many ways that you can take as long you understand the concept of the route. Which route are you going to take to move from point Q to R? Are we going to use the longer way or we're going to use the shorter way? We are going to reach the same and we're going to have the same answer. That is for a vector. We have the same answer. All right, let's consider question number 5. So this one, there was no need for any property. Yes, it's a property vector, but the shape there, we can't say a rectangle, we can't say it's a square, it's just a quadrilateral. It has got 4 sides. But I said a property vector is not just a name to say it's a property vector, no. Because also the properties of a shape are considered, like this question that we are having here, where we are given that in this fig 18.19, ORST, that is from O to R to S to T, it's a parallelogram. Why are they giving us this here? Because they know that you are supposed to understand your properties of the shapes. Remember, for a parallelogram, we say opposite sides are parallel and equal. Opposite sides are parallel. These are the most important part. We are not going to talk about the angles. The angles are not important for now. The one that enables us to use on a vector are these properties. Opposite sides are parallel, not just parallel, but they are also equal. So meaning to say, if I am given the vector of OR like this, I'm also given the vector TS, the direction also. Take note where the arrow is facing. Do not say because here it's R, there you just write R. No. It's not just an R that you're writing. The direction also. It's not about just being equal. They are parallel. It must face the same direction. The arrow is facing this direction. So if this is vector R, it follows that also this vector is going to be R. The whole of this line is going to be given as what? As R. The same thing if this vector is OT. The direction also from R to S, these opposite sides, they are parallel and equal. So this is going to be also vector T. The direction also considered, the arrow facing the same direction, same direction. Take note about that. Do not oppose these arrows. It's very, very important for you to know that. All right. So this is what we had on our parallelogram. These are the properties of the shape. So meaning to say, I'm already given RS. I'm already given TS. From these two vectors that I'm given. If it is a square, you use the properties of a square. All sides are equal, meaning to say all given vectors, they will be equal. Those are the properties. That's why we call it what? A property vector. All right, but it is not ending there. They are also giving us a ratio to consider here, where they are saying if ST from S to T, it is equal to 4SP. All right, this is what we have. This is S, this is P, this is T. They are saying ST is 4SP. The whole of this line ST, this one that we see, it carries this SP, this one, this SP that we are seeing, which is one of it. There's only one SP that we see. But in this ST, in this line ST, they are saying there are 4 of them. They are 4 of them. 4 of them. From point S to point T. If we count these SPs, there is 1, another SP, another SP, another SP. There are 4 of them. That is what they are saying. 1, 2, 3, 4. There are 4 parts of SP. So what does it mean? It means as a ratio, SP on its own, it is 1 part. What about from P to T? How many parts are there? It's going to be 4 minus 1, which is what? 3. So that means here we've got 3 parts that are remaining from P to T. So it's a ratio that you consider between SP and PT and the whole of ST. PT, it carries 3 parts. SP, it has got 3 parts because ST has got 4 parts. Oh, this is what you can do. You can try to write it as a fraction. ST is equal to 4 SP. You have it as a fraction. What does it mean? Divide by 4 here, divide by 4 here. This is what it means. It means SP here is equal to 1 over 4 of ST. 1 over 4 of ST. What does it mean? It means SP carries, or it only occupies 1 part. It's a quarter. SP, it's a quarter of ST. It's a quarter. It is a quarter. It carries only 1 part of ST. But what does the quarter mean? It means the ST has got 4 parts. ST like this, it has got 4 parts. 1, 2, all right, 1, 2, 3, 4. This is our ST. But SP occupies only 1 part like this. It only occupies 1 part. So it means the rest, these parts here, what are they representing? These 3 parts, they are for PT. So that the whole of ST, it gives us 4 parts. 1 plus these 3, we get what? 4 parts. 4 parts. Guys, this is ratio. Ratio is how many parts are there. How many parts are we having? So we saw that it can be simplified as SP is equal to 1 over 4 of ST. It's also very, very important for you to write it also as a fraction like that. It's very, very important. All right, no problem. Let's answer our questions, guys. Let's answer our questions. The first question, RA, was to find vector RS. All right, from R to S. So from R to S, this is the vector that you're already given, which is T. Remember, I said these are properties of it. You don't need to use a direction R, O plus O, this. There's no need for that. We said opposite sides of a parallelogram are what? Parallel and equal. So if OT is T, RS is also T. All right? It is the same thing with the vector TS. Vector TS is equal to what? Vector TS is equal to vector R, maintaining the direction of the arrow. It's vector R. But here they are not asking us on number B, they are not asking us vector TS. They are asking us to find the vector ST. Remember what I said, guys. The moment you are given TS, it means you are also given ST. ST simply means minus of the vector that you are given, which is minus vector what? Minus vector R. You are opposing. Just like what I was explaining between AB and what? And BA. If I am given AB, to find the vector BA, I don't need a diagram to go back to the diagram and find the root from here to here. No. Yes, we can do that, but it is not necessary. Know the properties of what? The shapes. Okay? Let's move on to the other one. SP. From point S to P, this is it here, SP. It means there is a need for us to apply the ratio now to use, our concept of the ratio. Remember from our ratio, we said SP is what? 1 over 4 of ST. It carries only 1 part. So this is it. Let us have it here. SP is equal to a quarter, which is 1 over 4 of vector st. This is not the answer. It's an indication. This is just like a root. You don't leave your answer here. You must substitute the equivalent to that. What is the equivalent of vector st? Vector st, we got it as what? As minus vector r. So we are multiplying 1/4 times minus r. So we are simply taking a negative. It's going to be negative 1/4 vector r. All right. Take note, you are multiplying by a negative. So it's not 1/4 minus r like this. No, this is wrong. It's like you're multiplying 2 times, like we've got 2 times minus x. It's minus 2x, not 2 minus x. Or x minus 2, no, minus 2x. All right? So we have the vector sp. Okay, let's move on. Rp. From R here to P. From R to P. This is what they want. So there are so many ways. We can move from R to O, from O to T, from T to P. But like I said, vector is a hence method. What am I trying to say? You work with the information that you have calculated before. All right. We have calculated before vector sp, which is this part here from S to P. So instead of me using this route where I do not have TP, I have to find the TP. Must find that. So to avoid all that, use the route that you already have the information from R to P. All right. This is the question. R, P. We are going to move from R to S. Then from S to P. So this is going to give us RS plus SP. Now let's simplify. So that means the vector RP is going to be RS. From R to S. From R to S, we are maintaining the direction of the arrow, going the same direction. So that's a plus. So it's going to be T, as it is a plus T. Then from S to P, there's nothing for us. If we already have this, we calculated this. The direction, yes, we are maintaining the arrow is a plus. We are saying we are going this direction, it's a plus. But plus what? The vector SP on its own is carrying a negative. So it's going to be minus 1/4 vector R. This is what you're going to have. So that means RP, we have to consider that the plus is for the direction that we are following, the direction of the arrow. But the minus here is for the vector SP on its own. It is already carrying a negative. So plus and minus gives us what? A minus. So that will be minus 1/4 vector R. So that is your vector RP in that case. And the last one was to find vector OP from O to P. Again, we can use advantage because just now we calculated RP. So from O to P, we can move which way? We can move which direction are we going to take? We can move from O to R, then from R to P because we calculated RP. So that we have moved from O to P. All right, let's just save it here. E, that is vector OP, is going to be from O to R, plus from R to P. Yes, you can use OT plus TP, provided that you must find vector TP. But like I said, vector is a hence method. Utilize the advantage of using that information that is already given there. So from O to R, we have it. From our diagram, just we are maintaining the direction. Remember, the direction of the arrow in this case was already this side. It was going this way. So as we are going this way, we are maintaining the positive R there. All right, so this is going to be positive R in place of what? In place of vector RP, this is vector R. And in place of vector OR, I mean, that's vector R plus RP. RP, we calculated this on our diagram. Yes, we want RP, but we already calculated this RP here. This is our vector RP, which gave us what? This is our answer here. That's T. So it's plus T like this. All right. Are we maintaining the direction there? We are maintaining the direction because that's what we have already. RP. So meaning to say we're just going to take it as it is. That is T minus 1/4 vector R as it is. So there we are going to collect like terms, just like our previous case. Vector R and what? And vector R. This is R minus 1/4 vector R plus vector T plus we've got vector T. But considering that R here is affected by what? 1. There's a 1 there. So we are subtracting 1 minus 1/4. So this is what you're supposed to have. 1 minus 1/4. So this gives us what? 3/4. Remember, 1 is same as what? 4/4. So that is going to give us what? 3/4. So you're going to obtain 3/4 of what? Of vector R. 3/4 vector R plus what? Plus T. So this is the easier way that we could have taken to work with the information that we are already given. We are already given that. Use the information that you're already given. So there are many questions to come that needs us to apply the properties of these vectors. The properties of the shapes. So we shall see more questions to come, and also typical exam questions containing vector 2 and also vector 1. So make sure that you subscribe to this channel, and also don't forget to share our platform to your friends and colleagues so that they also become part of the channel, Medzone African Motive. So like I said, more questions to come, more question papers also to come as we are revising. But for now, that's it. Till we meet again.